Who do you want to be part of your HSRP group? Just devices you deem to be allowed? Or any device, such as a rogue router that's been added to the infrastructure? I don't think we want those rogue routers being part of the group. Why? Because if they become the active forwarder, they may be doing so to cause a denial of service attack, meaning they are the forwarder, traffic's going to them, but they don't forward the traffic on. So all the traffic's getting dropped. Or maybe they are forwarding the traffic, but at the same time, they are making copies of every single frame they receive and sending them to a device that is performing packet capturing. And now what do you have? You have a man in the middle of attack. They are collecting all the information they need to launch a bigger attack potentially later on. So you want to control who is part of the HSRP group, and you can do so by implementing authentication. So with HSRP, we have two types of authentication. We have plain text authentication as well as MD5 authentication. MD5 is the preferred method because instead of sending the actual value of the password or the string you're using for authentication purposes across the network, you are sending a hash, an MD5 hash, and then that MD5 hash can be compared by both devices or all devices in the HSRP group to make sure that those hello packets are authentic, they are accurate, and as a result, we can control who is part of that group and ensure that no rogue devices join with the other HSRP peers. Configuring HSRP authentication is relatively simple. You'll go to the interface that is participating in the group that you want to configure authentication for. So in this example, interface VLAN 10. And the group we're working with is standby group 10. Notice the authentication keyword. So we'll type in authentication, and then we have the options of plain text authentication or MD5 authentication. So for plain text authentication, you can just type in your key string right there. So let's use a key string of Cisco. Don't do that in the real world, but as an example, we could do that here. And we would have to do the same thing on DSW2 because the key strings would have to match. The issue with plain text authentication is this string is going to be transmitted across the network in those hello HSRP packets, and they are in plain text. They're readable. They're clear. There's no obscurity here whatsoever in regards to this key string. However, if you want to specify MD5, which is much more secure in the recommended method, you type in MD5. So instead of the string itself being sent, it's a hash that's going to be sent. So therefore, the hash is sent with the packet, and then the device at the other end that receives the packet will compute its own hash, and if the hashes match, then the authentication is successful. So with MD5, you have two options. Take a look at these. You have key string and key chain. If you specify key string, you have the ability to simply specify the string of characters you want to use right now that will be utilized to create the hash. So if you specify Cisco or whatever combination of letters, numbers, and symbols that you want to use, up to 64 characters max, as you can see, you would do so. And this would have to match on both devices as well. And this will be static. It's not going to change unless you come and manually change it. If you want to take your authentication of HSRP a step further, you can use a key chain. So what is a key chain? Well, it is a item that has a bunch of keys on it. That's what it is. So you might have your car keys on your keychain. You might have your house keys on your keychain. And that's what we're dealing with here. We have a key chain. And this key chain can be unique amongst the different devices. So DSW1 can have its own key chain. DSW2 can have its own key chain. Just like you have a different key chain than your significant other or your friends. Everybody has their own unique key chain. However, on that key chain, if you want to access the same vehicle or you want to access the same door, you need to have the same key. Those keys have to have the same teeth so they can open those doors or start those vehicles. So the key chain can be unique, but the key ID inside the key chain or and the key strings associated with those key IDs have to be identical. So you would create key chains totally separate from HSRP, and then you would call upon the key chain here, and then the values, the key IDs, and the key strings associated with those key IDs would then be used for the HSRP authentication process. The thing about key chains is it gives you the ability to rotate keys. So you might want to use this particular key ID and key string for a certain amount of time, and then automatically behind the scenes transition over to using a different key ID and a different key string. That way there, the keys are always being changed that are used to generate that MD5 hash, giving you greater security. So it all depends how important the security is for your organization, and that will ultimately determine whether you're using plain text, key chains, or just simply key strings.